Hi guys, in this lesson is going to be focusing on how to find the area of a triangle when it's right angled. So here we have ourselves a triangle A, B and C. For this to work, for you to be able to find the area of a triangle, you need to know some side lengths and one angle. Now the catch is, you've got to know two side lengths and you've got to know the angle in between them again, just like when we did cosine rule. So here's the formula we're going to use, and it contains an angle, sine C. So that would refer to this angle in here. Now the formula says I've got to do a half times A times B times sine C. So I've got to know side A and side B as well. Alright, so just like with cosine rule, you need to know an angle and the two sides next to that angle to use this rule. Alright, so it's very important we know that angle on those two sides to be able to apply this formula. Alright, so here's our first example, and again it says find the area of that triangle ABC to two decimal places. Alright, so unlike using sine or cosine rule, there's no real decision making that you've got to do, because there's only one way to do area of non-right angle triangles. So let's go and see the important numbers we need for this question. Alright, so here's our formula, half AB sine C. Let's always start with the angle, because it's the most important one. The only angle we know here is this angle C. Alright, so we're going to have to use that. Now we've got to determine which one's A and which one's B. Alright, down here, opposite angle A is side length A, and over here, opposite angle B is side length B. This 8.4 here, side C, is just there to trick us. It's not going to help us do anything in this case. Okay, so let's follow the formula. It says we're going to do half of 5.8A times 4.3 for B times sine 112 degrees 34 minutes. Let's just check we've got these things right. We've got our angle, that's our sine C, and yes, we've got our two sides next to that angle that we're using in the substitution. Now it's just calculator work. Can we get 11.515, and it's ongoing decimal, but we're asked to do two decimal places this time. So the second value is the 1, so it's 5 point something. One after the 1's a 5, so it says round up. Alright, and we don't have any units, no centimetres or metres, so we're just going to say units squared. Okay, now I've chosen to attempt a past HSC question from all the way back in 2005, just to see how you guys are going. Alright, let's have a look at this question together and work out what we have to do. It says the lengths of the sides in the triangle are 7, 8 and 13 centimetres. Okay, so here's my triangle. Alright, and we know that all those units are in centimetres. Let's have a look at the questions actually tell us to do. It says find the size of the angle opposite the longest side, and it's giving us 2 marks for that. And part 2 says find the area. Well, I know the area one's going to be easy, right, because there's only one way to do that. Alright, so we've got what to do for that one sorted. But the first part may be trickier. Alright, so the longest side's 13, so we're looking for this angle here, theta. Now if this question wanted to be trickier, it may have said find the size of the largest angle. And that will be this one we're finding here, the largest angle always being opposite the largest side. Okay, so we've worked out which angle we're trying to find, but now, which technique are we going to use? Well, we can't use sine rule because sine rule requires us to have at least one full set, angle and side together. So we're going to have to use cosine rule. Alright, we're doing the angle version cosine rule. Okay, so here we go. Remember the A's and B's, the order doesn't matter, alright? 7 squared plus 8 squared. If you want to just always do the smaller side for A's, well, if you want to get a pattern going like that, it's always good. Alright, this is the one that matters though. The C is opposite the angle we want to know, which is that 13. Okay, so we put this in, it gives us a value of -1/2. Okay, so we do shift cos of that answer, and it gives us 120 degrees. All right, so this is now going to help us doing some things for the next part of the question. So let's go and write that 120 in there for our diagram. Okay, so the area of this triangle, remember we've got half AB sine C. Well, our C, sine C is the angle, so that's why our 120. A's and B's are those numbers either side of it. Okay, so we can put in our calculators 24.248. Now the question doesn't say how accurate, so I'm just going to say I'm doing it 24.25 centimetres squared, and I'm just going to let my marker know that it was 2 decimal places. So there we have it. Hope you enjoyed the lesson. You can go and do your homework practice, and remember, ask for help from your teacher on Google Classroom.